Welcome to Chapter 7, Ionic Equilibria. Okay, now we continue with titration curve for weak acid and strong base. Okay. Let's say we put 25 ml of 0.1 molar of weak acid in the conical flask and then 0.1 molar of NaOH strong base in the burette. Okay, so we will get basic salt after the endpoint. Okay, so we will get pH more than 7. Okay, this one you have learned from salt hydrolysis. When weak acid react with strong base, then we follow the one that is strong. So it will be basic salt. Okay, so there are few points on the graph that we must have some idea how to draw. Okay, that is first before titration. Okay, in the conical flask, there is only weak acid. Okay, so if it's weak acid, means that pH is less than 7 because there's only acid. And then we haven't started to titrate with strong base yet. Okay, so at equivalence point, okay, means the weak acid, the volume is always constant. Okay, and then we add 25 ml of 0.1 molar of sodium hydroxide to reach equivalence point. Okay, then we will get pH is more than 7, not equals to 7, because this is a basic salt when weak acid reacts with strong base. Okay, then after equivalence point means that our titrant NaOH base, okay, will be more than 25 ml. At this time, it will be also more than 7. It will contain basic salt and also excess base. Okay, so there are 3 points that you must understand before titration, less than 7 because there is only weak acid. Okay, then at equivalence point, it is more than 7, not equals to 7 because it is a basic salt when weak acid reacts with strong base. Okay, then after equivalence point, we have more base, so it will be more than 7. Okay, let's look at how to draw the graph. Okay, so first of all, just now we have already mentioned that in the conical flask there is only weak acid. Okay, so when no NaOH is added, the pH must be less than 7. Okay, of course you can calculate the pH because it is given here 0.1. So we know pH equals to negative log H3O plus. So it is equals to negative log 0.1. Okay, so we can calculate to get the initial point, initial pH and plot the points. Okay, after that, remember the second point will be at equivalence. Okay, the equivalence point, remember, must be more than 7 because it is a basic salt. Okay, now next one. What is the difference between strong acid and strong base titration curve? Okay, first of all, pH is more than 7 for weak acid and strong base. Another one, it contains buffer region. Okay, remember at this point, okay, we still have weak acid. At the same time, salt has been formed. Okay, however, you can see that in this part, okay, that the pH does not increase, okay, significantly. Okay, it increased a little bit only, okay, or do not change much, or we say that pH is maintained here. Okay, because it is a buffer solution. When strong acid or strong base is added, the pH will maintain. Okay, so remember to draw the titration curve for weak acid and strong base. Okay, remember the strong base will tell you that it is a basic salt, and the pH at equivalence point will be more than 7. And don't forget to plot the equivalence point. Okay, so that's all for the titration curve for weak acid and strong base.